Hello and welcome to this video lesson. In this video, we will be looking at the sine rule. There are different ways of coming up with the sine rule, and the method I'm going to use is I'm going to use the triangle ABC here, and I'm going to draw a height which is perpendicular to base A, and I am going to write two sine rules based on a right triangle. So I'm going to take this right triangle and I am going to write that sine C is equal to the opposite. So this is C, the opposite H, and hypotenuse B, so it's H over B, meaning that H is equal to B sine C. And I'm going to take this triangle over here, and I am going to write the sine rule for this. So sine B is opposite, which is H, over hypotenuse of this triangle, which is C. And that gives me H is equal to C sine B. Now I know that H, I'm going to substitute these two together, and I'm going to get B sine C is equal to C sine B. And I'm going to rearrange this to say that B over sine B is equal to C over sine C. And that's pretty much the sine rule, and you can use this logic. You can draw another height for a different base, and you will come up with the fact that A over sine A will also be here. So this is pretty much the sine rule, and if we take the reciprocal of everything, we can also write it as sine A over A is equal to sine B over B, which is equal to sine C over C. The sine rule is an excellent tool to use when we're looking for a missing side and we're given two angles. So in both of these cases, we're given two angles and we're given one of the sides and we have a missing side. So to use the idea, in this case, we know that this is our length and this is the angle, kind of opposite to it. So x over sine 40 should equal to 20 over sine 30. So let's write that out. So x over sine of 40 is equal to 20 over sine of 30. And we can rearrange this and write it as 20 sine 40 over sine 30, and we can put that in our calculator and we would get that x is approximately 25.7 meters, and I am going to highlight that. For this second example over here, we know that x over sine of this angle, which we don't actually have, is equal to 10 over the sine of this angle. We don't have this angle, but we know that all angles in a triangle add up to 180. This is 120, this is 30. So this angle over here is 180 minus 120 minus 30, which is actually 30 degrees. And remember that our diagrams are not to scale. So here we know that x over sine of 30 is equal to 10 over sine of 120. I am going to rearrange this as x is equal to 10 times sine 30 over sine of 120. 30 and 120 are both special angles, so we can write this as 10 times half divided by root 3 over 2. And we end up getting the 2's cancel out. And we're left with 10 over root 3, which is actually 10 root 3 over 3. We can also from here use technology and just put it on a calculator and get an approximate answer of 5.77 meters. Even though finding sides is very easy using the sine rule, finding angles can be a little bit more difficult. So let's examine this situation. In this situation, we're given side 10, side 5, angle 20 here, and we're trying to find this angle over here. I'm going to call it theta. And we can just use the sine rule and say that sine of theta over 10 is equal to sine of 20 over 5. And this is simple enough because sine of 20 over 5, sine of theta over 10, we can rearrange this and say that sine of theta is equal to 10 sine 20 over 5. And then sine theta is going to be approximately 0.684. And I'm just using the exact values in my calculator. And I can calculate angle theta to be approximately 43.2 degrees. Now, this is easy to see, and it kind of makes sense because if this is 43 and this is 20, this angle will be a little bit more than 90, so it'll be an obtuse angle. And this triangle really works out pretty well. However, we got to remember that in a unit circle, all the sine values, which are also the y coordinates of any points on a unit circle, are positive values. And we know that we have sine theta here being positive, and the corresponding angle to it is approximately 43, so that's this value here. But there's also an obtuse angle right here, which will give me the same sine theta value of 0.684. And to find that, I know that the whole circle, one whole line is 180 degrees, and if this is 43 degrees, angle from here to here is 180 minus 43.2. So I can write, so theta is this, theta is also approximately 180 minus 43.2 degrees. And this will give me 136.8 degrees. And once I calculate this, I just have to ensure that everything makes sense. So I know that this is 20 degrees and this is 136. And if I add these two, I got to make sure that they don't add up to anything more than 180. And when I do add these, check. 136.8 plus 20 will give me 156.8, which is smaller than 180. So these two values can both actually be correct. And if I were to draw this on my triangle over here, we can see that if this is 10 and this is length 5 and this is 20, length 5 can also be drawn here, and we can have a second triangle with length 5, and this theta value over here is actually corresponding to the 136.8. And this theta value over here is just corresponding to this theta value 43.2. So whenever you're using the sine rule to find an angle, you got to be very careful. You got to make sure that you calculate both of the angles and go back and check to see if the angles that are being added are adding to an angle which is less than 180 to actually accept this. Let's take a case where we find the two angles and we have to reject the second value. Let's try an example like that. Okay, in this second example, we have a triangle with length 7, 10, and an angle of 55 over here. And we want to calculate the missing angle, and our missing angle is this angle over here, which is theta. I'm going to give some units, centimeters, to both, and let's calculate. So we know that sine theta over its corresponding side, which is 7, is equal to sine of 55 over its corresponding side, which is 10. Rearrange this and we get sine theta is equal to 7 times sine 55 over 10. And sine theta turns out to be approximately 0.573, and our angle will be approximately 35 degrees. We know that angle can also be 180 minus 35, which will be approximately, I'm going to write this 1 and this is 2, 145 degrees. Now, to check to see if the second angle works, we got to make sure that the new triangle formed will actually work. And for it to work, we need to make sure that all angles add up to 180 or less. And we know that one of our angles is 55, the other one is 145. And if we were to add these, 145 plus 55, we would get 200. And we know that 200 is actually more than 180. So we actually can't form a triangle using this 145 degrees. So our only answer here would be the 35 degrees. So just to backtrack and tell you everything about what you need to do when you are looking for an angle, make sure you use the sine rule to find the angle, get the corresponding angle in quadrant 2, in this case it was 145, add that angle to the other angle and make sure that it's less than 180. If it's less than 180, it's acceptable. If it's more than 180, then you cannot form a triangle with it.